All right, freak. So whenever you want to show that two functions are inverse functions of each other, what you need to do is prove the following. If you get f of x and a g of x, so let me put this right here, and g of x, and you compose them. In other words, you do f of g of x. If after you compose them, in other words, you plug in g of x into f of x, your answer comes out to x. And then you do it again, but backwards, g of f of x. If they both equal to x, then they are inverses. Okay? Let me rewrite that over here. Inverses. So our f of x is the cubed root of x plus 1. And our g of x is x cubed plus 1. So let me first do f of g of x. Okay, so f of, now g of x is x cubed plus 1. That means I'm going to plug in x cubed plus 1, this thing right here. I'm going to plug it in to where that x is right there. Notice I plug it into the f function, okay? So it's going to look like this. The cubed root of, instead of x plus 1, I'm going to write x cubed plus 1. And then there's a plus 1. That extra plus 1, this right here, is this little piece right here. Okay? Let me make sure that was right. X cubed plus 1, x cubed. Yeah, okay. So what we end up getting here is the cubed root of x cubed plus 2. Now this is all you can get with this. Like, this is your answer. You can't simplify this anymore. There's nothing you can do with it. So notice how one of the requirements was that you had to get right here, okay, that f of g of x was equal to x. Notice f of g of x is not equal to x. Okay, I'm gonna put right here, not equal to x. Okay, so that means that these are not inverses. Okay, they're not going to be inverses. Now, just to kind of double check it, let's do g of f of x. So g of f of x. G of, now f of x is the cubed root of x plus 1. Okay, now I'm going to plug in this big old cubed root of x plus 1 right here where the x is, okay? So that's going to be, let me just do it here in red. Cubed root of x plus 1 to the third power plus 1. Now the cubed root of x plus 1 to the third is just x plus 1 plus 1. This is x plus 2. Okay, which is fine, but it's not x. Remember, in order for these things to be inverses, f of g of x has to equal to x, which has to be the same as g of f of x. But these answers do not match, and they're not just x's. So these are not inverses. All right, now for this last one, this one's actually pretty easy. You just have to have a little bit of understanding of where the parts go. So when they tell you that you have a rational function, rational functions usually look like this, like something over something. Now, your vertical asymptotes are on the bottom. The horizontal asymptotes are on top, and also on top are your intercepts, okay? So you just have to know how to write them. There's a nice little trick that I teach my students. So here you go, okay? Check this out. F of x is, all right, now, they said you have vertical asymptotes at -1 and 4, okay? So it's always the opposite numbers of what they give you. So you see -1 and 4, I'm going to write x plus 1, x minus 4, okay? Because it's the opposite of what they gave us. They gave us a -1 and a +4. So I'm going to go with a +1 and a -4. So far so good. Now, they say that the x-intercepts have to be at -6 and at +3. So again, I'm just going to write x plus 6, x minus 3, the opposite of what they said. Okay, so there you go. Now I have my x-intercepts, I have my vertical asymptotes. Now just for the horizontal asymptote, they said the horizontal asymptote is -2. So just do this and you're done. Okay, that's it, you're done. Now just to kind of prove it to you that everything seems to be okay, let me show you what this graph looks like, the one I just wrote out on Desmos. It's an online graphing calculator. So here it is, here's Desmos. Let's look at where my intercepts are. The x-intercepts are at -6, and 3, exactly where they're supposed to be. My vertical asymptotes occur at -1. So right here, okay, let me take a screenshot of this so I can kind of draw on it. Give me a second. So right here at -1 is a vertical asymptote, and also at a +4, that's a vertical asymptote. So there's your x-intercepts right there, your vertical asymptotes right there, those big vertical lines, and it's not supposed to pass -2. And check it out, there it is, it's not passing -2. So all those things right there that they mentioned in the problem are true.